All right, good morning. Welcome back. Just by way of recap, you should have finished your Desmos that we started in class on Monday. It was the one called Match My Line. Now, when you do that, when I looked about a half hour ago, there were several of you who had not finished that yet. So you best do that sometime today. When you go through the Desmos activities, a lot of them, they're like, there's a correct answer and an incorrect answer. It'll give you a check mark if you got it correct, or it'll give you an X if you got it wrong. Does it spit that out for you guys on your end? Does it indicate like, hey, you got it right, you got it wrong? You're saying yes, but you're saying no? So if you change, if it says put a line through these 2 points, and your line goes like this and it misses the second point, does it say, hey, you got it wrong, keep working?
No.
See, Aaron's saying yes.
Well, it like indicates in the question it has to go through the point, so if it doesn't go through the point.
Right, oh, so you're just looking at it yourself saying, obviously I haven't done this correct yet. Okay, it doesn't actually tell you. See, like now on my screen, when I pull up the summary, I can go to like Aaron's name and it'll say step 1 check mark means it's good. Step 2 check mark. Step 3 check mark. Step 4 X. That means he did something wrong on step 4. So I can go through. Now I'm not going to go through and necessarily pick out every single little mistake and give you a grade on that. It's really more of a completion exercise. But if you have nothing but X's all the way across, that tells me you didn't even put any effort into it. So that's what I'm looking for when you complete that. And it's just practice. It's practice understanding slope and intercepts, things that you did in the 8th and 9th grade, but this is all good review. So the other thing that you should be caught up on, we're actually going to work on section 1.6 today. That means you should be either done or have been very close to done or working on quizzes 1.3, 1.4, and 1.5. Okay, some of you are, some of you are not. Okay, so don't fall too far behind on that. Here's what I want to do today. We're talking about section 1.6. We're still talking about linear functions, but now we're actually going to start modeling it, doing some applications with linear functions, not just, drawing lines like you guys did on the Desmos. Let me go to, in your textbook, I got example 4 and 5 on page 49. So this is page 49 of your textbook, and it says, example 4, let's do this with our computer, with our GeoGebra, okay? We'll use the tool to help us. It says a tech startup is looking at developing and launching a new mobile app. Initial development is $300,000. They estimate that marketing and support will be 50 cents. You can already see there's a linear relationship there, right? The $300,000 is the starting amount. The 50 cents per user is going to be the additional cost, and that'll be the slope. It says now the app is free, but they estimate they will be able to bring in $2 per user on average from in-app purchases. How many users will they need to break even? So let's go to a graph. Now if you scroll down, you can already see the graph in the textbook, but let's build our own. Okay? First of all, let's label our axes before we even get started. We've got an x-axis, that's our independent variable, and we've got a y-axis. How are we going to label them? Which one is which? What's our x? Remember, we go to graphics, and I can go over to this x-axis tab. What are we going to call it?
Revenue.
Not revenue. Cost is going to be our dependent variable. The cost is going to depend on the number of users, right? Isn't that what it said, the number of users? Sometimes it's easy to identify which one's the independent variable and which one's the dependent, which one's X and which one's Y. Other times it's like, wait a second, I'm not sure. So you got to ask yourself, does the cost depend on the number of users? Or does the number of users depend on the cost? in this particular situation, they're saying the cost is dictated by the number of users. That's what they're saying, right? And so is the revenue, also dictated by the number of users. So for sure, our x-axis is going to be users. Do you guys agree? The number of people who use the app, that's our x-axis. Okay, what's our y-axis going to be? Well, we said it's cost, but we also said it's going to be revenue because there's actually two graphs going on here, right? So maybe we can just call it dollars, and that'll cover both. You guys comfortable with that? So let's just call the y-axis dollars. Everybody remember how to get to this screen so you can punch in your labels? Okay, so then I'm going to close that. So I've got users and I've got dollars. Okay, let's talk cost first of all. Cost. What's the equation for cost? It gave it to us, right? 50 cents per user plus what? 300 grand, right? So how do I type that in? It's y equals mx plus b, right? 50 cents, I can go 0.50. I'm going to go in my input bar. 0.50 or 0.5. 0.50 times what? X, because that's our number of users, plus, what's our y-intercept? 300,000. Okay, so it went way the heck off my screen. So now I gotta pull down my y-axis until I can see 300,000, which is a long ways to pull it down. There's 300,000. Okay. Now it looks like a flat line. Why does it look like a flat line? Because we're in the hundreds of thousands here, and our slope is only 50 cents. But how could I make that line look more like it has some slope? I got to drag the users over too, because this is only 25 users, right? We might want lots and lots of users. So let's say I drag this guy. There's 400 users, 500 users. There's 18,000 users. And now you can see that line, I'm going to drag this down again too, the line is starting to look like it has a little bit of slope to it, right? So it's all about how you manipulate your axes. Okay. So notice that when you type something into GeoGebra, we didn't type in the f of x equals. We just typed in the 0.5x plus the 300 grand. It automatically just calls it f. And if we do another one, it'll call it g, and if we do another one, it'll call it h. That's just the default, okay? What would be a more appropriate letter if we're trying to keep all of our stuff organized? F is fine. A? Why A? I was thinking of a different letter.
I don't know, money.
Money?
Not for
A for amount. We're going to end up doing two of these, right? What does this line represent? What word? Go back to the problem. Initial development of the app is 300,000. Marketing support will cost. Cost, right? This is the cost to the company. So I'm going to call it C. So I'm going to right click on it. I'm going to rename it, and instead of F, I'm going to call it C. And now I have C of X. So now when I look at C, my brain thinks cost. Do you have to do that? No, not at all. It's just an organizational technique that you might want to think about as you're trying to keep all your stuff straight. Okay, what was the other function? They're going to make money, right? $2 per user. And Will, I think you dropped the word earlier, revenue, right? When we bring money in as a company, we call it revenue. So what's my equation? $2 times what? Just X, right? $2 per user. So notice both of these are straight lines. Obviously, this one's going to have a y-intercept of 0 because if we have 0 users, we're going to have 0 revenue, right? So instead of F, notice it defaults to F again. I'm going to rename mine. I'm going to call it R for revenue. And now I have my two equations. And the question is asking us, How many users will the company need to break even? So those of you that are business majors, or maybe you've taken some of these courses already, you should, whether you're a business major or not, you should know what cost means, what revenue means. And if you take your revenue and subtract off your cost, what do you get? Profit. Exactly. So notice that the revenue, the red line, is below the green line. So right now we are spending more money than we are bringing in. You guys see that? But as we get more and more people to use our app, obviously the cost is going up, but notice that the revenue is going up faster. It's a steeper slope. So the red one is catching the green one over time, right? The question is, how many users do we need in order to break even? So graphically, what are we looking for? We're looking for the intersection. We're looking for that point right there. It looks like it's going to be about 200,000 users if I use my eyeballs. But if I don't trust my eyeballs, I can trust my computer to do this. I want to put a dot right there. You guys remember how to do an intersecting dot? Have we learned that one yet? Go up to your new dot tool. It's the A, the new point, and click on intersect. I want a dot where two things intersect. And what things do I want? I just click on the green line, I click on the red line, and it gives it to me. And sure enough, it gives me point A, which is 200,000 comma 400,000. What does that mean? Remember, X 200,000 users will result in a cost of 400 grand. It'll also result in a revenue of 400 grand, meaning if I subtracted my cost and my revenue, I would break even. And anything more than 200,000 users, now my company is going to turn a profit. What do you guys think? Not rocket science, right? We're just comparing two lines. Now, could you have done that with paper and pencil and never pulled out your GeoGebra at all? Sure, you definitely could. And I encourage you to do that if you want. My brain tends to think this way, though. Like, the picture really helps me. Comments or questions on that? We feel okay there? Let's try another example. Which one did I say we were going to do here? Let's try example 5. I'm going to scroll down. So right before we get to example 5, our textbook talks a little bit about supply and demand. This is another business thing, right? Where if you have a product, the lower the price, there's going to be more demand for that product, right? And then as the price gets higher, there's less of a demand, right? Who makes more cars, Chevy or Ferrari? Chevy makes more cars because there's a higher demand for a Chevy than there is a Ferrari, right? Not as many people can afford to buy the Ferrari. There's a lower demand for the Ferrari, but their price is also much higher, right? So supply and demand, how it works together. Let's just go through an example. Okay, they're talking about gasoline here. Example 5. At a price of $2.50, there's a demand for 42,500, but there's only a supply for 20,000 gallons. Think about that for a second. If gas costs $2.50, a lot of people are going to want to buy that gas. How many people? Or how many people are going to want to buy how many gallons? They're going to want to buy 42,500 gallons of gas. However, at that price, we can only supply 20,000. What's going to happen? There's going to be a shortage of gas, right? So what should we do if we are the people selling the gas? We need to raise the price. So then it says if we raise it to $3.50, people are going to want to buy 25,500, and we will be able to get a supply of 28,000, meaning we have enough gas to cover what they want, but actually we have too much gas. We're going to have gas left over, right? So the question is saying, assuming that supply and demand are linear, for what we're doing right now, supply and demand are just straight lines. We know that when we get into more complicated stuff, supply and demand are not always straight lines. They can curve this way and whatever. But for now, we're just talking straight lines. So that's why it says, assuming that they're linear, find the equilibrium price and quantity where we won't have too much gas, but then we also won't run out of gas. Well, you can already predict that the price is going to be somewhere in between $2.50 and $3.50. It's just a matter of where, right? somewhere in between. So let's go and make a new graph again. I'm going to just go File, New. I'm not going to save my other one here. Okay. Again, let's label our axes before we even get started. What can we do to label our x-axis? Now, we can actually do this either way. Does the price of gas determine the number of gallons of supply and demand, or does the number of gallons for supply and demand determine the price? You could probably argue it either way, couldn't you? So let's just make a decision right now. Which way do we want to go with our axes? Let's call the x-axis the price. So I'm going to call my x-axis price of gas in dollars. You can be as descriptive as you want, but usually the better descriptor you provide is better. How about the y-axis then? Remember, we're going to have two curves, so I can't call it supply and I can't call it demand, but both of them are in what unit? Gallons of gas, exactly. Gallons of gas. Okay, so I've got my axes labeled. Let me bump up my font size for you guys here. I've got my axes labeled, so let's plot some points. It said at $2.50, the demand is 42,500 gallons. So let's go 2.5. 2.5 is my price. And let's just label this. I'm going to do 42.5. Notice that I could do 42.5. I could also do 42,500, right? Because isn't that what they're saying? So if I do 42.5, and I scroll down so I can see 42.5, is my y-axis correctly labeled? It's not 42.5 gallons of gas. What would I need to change here? Yeah, in thousands. So I'm going to change my y-axis. I'm going to say, where am I at here? Shoot. Sorry. That's not what I wanted. Graphics. That's what I wanted. Y-axis. I'm not going to say gallons of gas. I'm going to say thousands of gallons of gas. Or gallons of gas in thousands, if you wanted to say it that way. Does that help? I'm being real kind of anal and picky about organization. You see that? I'm trying to get you to attend to precision. You're going to be precise with everything you do. Your labels are precise. Your graphs are precise. The way you display it is precise. Okay. So that 42.5 is a demand number, right? 42.5 is demand. Let's go to the other data and do demand as well. So at 350, the demand is 25.5. So I'm going to graph 350 and 25.5. Okay, so I've got 2 points. They're both demand. Do you guys agree? I haven't even talked supply yet. We're just talking demand. Okay, so now it says assume that it's linear. Let's connect these two guys with a line. And then I'm going to click on my line. I'm going to change it into y equals mx plus b form. Notice it's not in function notation because I made a line, not a function. That's okay. It doesn't matter. And I'm going to stretch out my x-axis because I don't need to see $23 gas. I hope I don't need to see $23 gas. We'll be realistic about what the price of gas is going to be. Let's go no higher than $5. If we go higher than $5, I'm getting a different car. You guys might be too young to remember this, but gas was like $4.79 like 10 years ago, 20 years ago. Yeah, it was crazy. Around the time you guys were born, gas was over $4 a gallon. Okay. So what could I call this line? Right now it's called F. I could rename it. Rename it what? What do you think? We just plotted price and gallons, but they were both gallons of supply or demand. They were demand, right? So I'm going to call it D for demand. So this only gives us half of our information. Basically, they're saying as the price of gas increases, as we travel to the right, the more we charge for gas, what's going to happen to the demand for gas? It's going to go down, because as it gets to $4 and $5, people just aren't going to be willing to buy it anymore. So the demand is going to go down. But if we start selling gas for 20 cents a gallon, everybody's going to want to be buying gas. See the relationship here? Okay. So now, which way do you think supply is going to go? Let's take a look at it. Yeah, it's going to go the other way, right? So now let's go to supply. At 250, the supply was 20,000. So let's make another point. At 250, the supply was 20. So now I have that point on there. And at 350, the supply is 28,000. So at 350, the supply is 28. So now I have points C and D. I can make a line through points C and D. I can right-click on that line, change it to MX plus B form, because that's the way I like to see it. And I can rename it, instead of F, I'm going to call it S for supply. So now I have a supply line and I have a demand line. What were they telling me to find? The equilibrium, where the two intersect. So I'm going to find the intersection point. I'm going to click on my first line and my second line. It gives me point E. So this is just a XY coordinate plane, but you have to understand what it means. What is the 3.4? Price, $3.40. If we price gas at $3.40, we will have both a supply and a demand of 27,200 gallons of gas. So it's the equilibrium. So if you were the person who owned the gas station, you would want to probably sell your gas for $3.40, right? Now, is that the way we price gas? Of course, it's way more complicated than this. This is such a simplistic example, right? But understanding the linear relationship of two things and looking for the intersection, equilibrium, profit, revenue, cost, that's kind of what we're getting at. Comments, questions? Go ahead, Aaron.
How do you get that algebra bar out on the side?
So yours is not here? Yeah. Go up to View and look for the word algebra and click on it. I bet yours just got turned off.
Is View on my computer?
Yeah, it'd be on your top menu. It might be different on a Mac. Yeah, way up top, View. See it? You were right on it, right there. And then click Algebra, way at top. There it is. Yep. Yeah, sometimes you accidentally, if I accidentally click on this X right here, I'll close it. And whoops, there goes my algebra. But I can turn it back on by...
It's been on for 2 days now.
Yeah, without that algebra screen, yeah. I mean, you can do things, but it's sure nice to have it. Remember, this is the software is called GeoGebra. There's the geometry screen and the algebra screen at the same time. So the idea is that they work together. Yep. Any other comments or questions on that? Not bad. We won't go through this whole example, but let's look at try it on page 52. It says, a company estimates that a price of $1.40, the demand will be $4,000. And for every $5 increase in price, the demand will drop by 200. Notice they're not giving us a second point, but we could generate a second point based on that information, right? So I'm just going to go File New again here. Get rid of this gas one. Try it on page 52 says, a price of 140 is 4,000 items. 140, 4,000 items. Options, font size. So 140 gives us a demand of 4,000 items. If we increase the price by $5, the demand goes down. So let's just plot a second point. If we increase the price by $5, so now it's 145, it goes down by 200, so that'd give us 3,800. So we again have 2 dots. Both of them are supply. There they are. I can make a line that goes through those 2 dots, and I have a supply curve, which happens to be a straight line. Then it says the supply curve, price equals, they often use P for price and Q for quantity. So the price equals 1/20th of the quantity. Okay, so this is where we're going to get backwards because of the way Jamie did it. What happens if I do 1/20th of X? Is that the relationship I'm looking for? Where this guy, this first black one, was my supply, and this one is my demand. I'm telling you it's wrong. Somebody tell me why it's wrong. What did I do here? Well, it does. It's just it's going up at a very, very rate. The slope is barely increasing. Let's go back to this one. When I plotted 140 comma 4,000, that's X comma Y, right? 140, was that a price or was that a quantity? It's a price. So I did price, quantity, then I did another price, quantity, right? Well, when I go here, which one is the price and which one is the quantity? It said the price is equal to 1/20th of the quantity. Isn't that what it told us? So here I'm using X as my quantity and Y as my price. But up here I used X as my price and Y as my quantity. Do you see how that's an easy mistake to make? This means nothing. This is gibberish that I have up here because I've flip-flopped my 2 variables from one line to the other. So either I got to fix this guy or I got to flip these. I got to make this one 4,000 comma 140, 3,800 comma 145, or I need to change this guy into, instead of 1/20th of X, his inverse would be 20 times X. Do you see where I'm going with this? Okay, so I'll just I'm going to flip my A and B. So I'm going to double click on this, and instead of 140, 4,000, I'm going to go 4,000 comma 140. I'm going to flip them around. And then instead of 38, this one here, I'm going to go 3,800, 145. 3,800, 145. Okay. Now my data is appropriately done. I haven't labeled my axes, but I could label my axes if I wanted to, right? Now I'm talking, this is the quantity of items, and this is the price, correct? And now I could find my equilibrium again by finding my intersection point. If I charge $160, I will have a demand and a supply of 3,200 items. How do we feel? Does anybody's brain get turned around a little bit when you start thinking which one is demand and which one is supply? It does for me. So that's why we're going over this, just so you can feel and practice that a little bit. So you're going to get examples like this in your 1.6 quiz. where you'll have to analyze quantity and demand and supply and stuff like that. Let's try, I got one other activity. I'm going to get rid of this. You can keep your GeoGebra open because you might want to use it for this activity. Did we watch the graduation video the other day? Yeah, we did that? Okay, I'm going to show you another video. I'm a big fan of this guy. There's a math teacher, his name's Dan, that he makes these videos. He made the graduation one too. I'm going to show you another Dan video. So if you go to course docs and links, you can go follow along with me if you want. If you go down to section 1.6, that's where we are today, it says 3-act cup stacking. Okay, I'm going to show you a video. It's only a few seconds long. Pay attention. We'll watch it more than once. Are you ready? I'll let you watch it one more time and then we'll talk about it. Here it is again. Okay, somebody explain to us what the heck's going on here.
How tall cups are?
We're measuring how tall cups are. Specifically, it feels like it's like a race between the white ones and the blue ones.
When the white one overtakes the blue one.
Yeah, like what happened at the very, very beginning. If you just did one cup, who wins? Blue. The blue's a taller cup, right? But then what happened when we got all the way to 20? Yeah, by the time we got to 20, the white overtook the blue. 20 whites is taller than 20 blues, right? So go ahead, Gage. What are we going to try to figure out?
When they're the same.
Yeah. We know that one cup, blue wins. We know that 20 cups, white wins. The question is, how many cups make it so that it's a tie? That's what we're going to try to figure out. Okay? Now, is there any additional information that you feel like would be beneficial to you here?
Dimensions of the cups.
The dimensions of the cups? Yeah, like how tall are they, right? Let me show you a couple other pictures. This is Act 2 here. This might be information that you want to know. It shows you how tall one white cup is. It also shows you the thickness of the lip of the cup when they get stacked. Do you see that? So that's the white cup. And then my other one is the blue cup. Notice the blue cup is taller, 12.1 centimeters. But notice the lip. The lip is only 0.8 when you stack them, whereas the lip of the white was thicker, was it not? Okay. I want you to mathematically figure out how many cups were present. The blue and the white, it was the same number of cups, right? How many cups were in the two stacks when they were the same height? Okay? Make sense of the problem and persevere. Construct a viable argument. Model. You can use your GeoGebra. You can use paper and pencil. When you have an answer, flag me down. Let me see what you got. Yeah, this is on Blackboard too, so you guys could pull this up if you want.
Just the blue cup.
This is the blue cup image. And I'll open the white cup image too.
only the blue cups on my blackboard.
What? It doesn't look just like mine? Right beside Act 2? One's a JPEG, one's a PNG.
Yeah, no, I just have stacking cups and actual blue cups have PNG.
Yeah. Yeah, that's the other one. There it is.
Oh.
Yep, sorry.
Question.
Yeah.
Why didn't I put the pictures?
Under course docs and links.
Oh, okay, that's not.
Yep. Anything that's like not a quiz or part of the schedule or something like that, that course docs and links is where I'm putting all the PowerPoints and the pictures and the videos and stuff like that. Now be careful when you do this. This is a hair more complicated than you might think. So I definitely want you to double check your work. You know, if you're doing it by hand, throw it on a graph on GeoGebra and double check and see if it makes sense. Anybody got an answer yet? Good question. Can it be a decimal? When you saw the very end of the video, did it look like we sliced off some of the cups? No. So if you got a decimal, what would be the appropriate thing to do? Round to the nearest whole number cup, right? Who's got one? What'd you get?
I got around 6 cups.
Okay. First of all, your two answers should be exactly the same because that was the idea. We started with 1 versus 1, and then it went 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way up to 20, and then back down to 19, 18, 17, 16. So your two answers should be the same. The number of white and the number of blue should be the same. Anybody else? Yours is wrong, by the way. I want you to think about what you did. Anybody else? Great. So what decimal did you get? Okay. The fact that you got a decimal is not wrong, because when I solve it, I get a decimal as well. And what did we just say? You're going to have to round to the nearest cup, right? But that is not correct. I think you made the exact same mistake that Landon made. If you're plotting this on a graph, pay attention to your y-intercept. That would be 0 cups, right? What should the height of 0 cups be? Should be 0, right? So does the y-intercept really have a place here? It kind of doesn't make any sense, right? So what about 1 cup? You guys know the height of 1 cup, right? Could you figure out the height of 2 cups? You should be able to, based on the information that you have. So the y-intercept is not going to have any reasonable application in this particular model, because 0 cups doesn't, we're kind of starting with, our domain is starting with 1 cup. We're not even counting 0 as a possibility. You should be able to develop an equation that represents the height of the blue cups. The height of the blue cups is equal to blah, 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 where your independent variable is the number of cups, and your dependent variable is the height of the stack.
Over here.
So you are at, what you're doing right now is you're saying every single time I add a cup, because you have X for the cups, right? Mm-hmm. Every time I add a cup, I'm adding 11.3 in height?
Yeah.
I don't think so. That would be if they stacked one on top of the other, but they overlap. Right? When you stack 2 cups, it's not the same as taking 2 and the height of 1 and doubling it, right? Because they stack inside of each other. This is one of those examples that, I'm going to be honest with you guys, this came out of an 8th grade math book. Now, I don't mean this, I don't want to say like, you guys are struggling with an 8th grade problem, because it's a complicated problem, okay? But the mathematics behind it is no more than y equals mx plus b. So what do you really have to do? You have to make sense and persevere, and you have to attend to precision. And once you do that, and you keep all your data straight, and you get your equation of your line, you're going to be like, oh, yeah, okay, no problem. But it's not easy. It can really get you turned around, and that's why we're practicing it. So what's your answer? Point E? Yeah. So what would you round that to?
7.
Yeah. Very nice. So just humor me now and right-click on your F and G, your 2 black lines, and change them into y equals mx plus b form. It's a little easier, cleaner to see that way. Now, can you can identify the slope and explain what that slope is?
Oh, that's the changing the weight.
Very nice. Very nice. So, now that you have that, Landon, once you have a correct answer, I would like you to look at what we call the Swivl on Blackboard. It's right below it. It says Swivl. Read that part and see if you can figure that out. Who else has an answer? Were you raising your hand? Nope. Okay, remember. Well, first of all, you should be able to make an estimate. Our answer is going to be between what 2 numbers? Based on the video that we just watched.
0 and 20.
It's going to be between, definitely 0, but even 1, right? Because with 1 cup, the blue was taller. Our answer has to be somewhere in between 1 and 20. So our answer is either 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, or 19. It's one of those numbers. Oh, you're already on this.
Oh, that's what we're doing.
We're still trying to figure out the first part.
Oh.
Have you figured out the first part of when the two stacks are the same height.
Oh,
Yeah, I hadn't even gotten to the Swivl yet.
okay.
We're still on our original question.
Okay.
Yeah, you might very well be correct, by the way, with that Swivl. I haven't looked at the answer for that one yet. Anybody else got an answer here? Did you see what you did wrong yet, Dalton?
No, I have not figured it out. I'm just gonna start fresh out. Delete everything.
What do you got going on here?
I got 7.
Very nice. Very nice. What do you got going on here?
Nothing, right?
So, if you're lost, you can always just plot points, right? Make yourself a little grid and make a blue and a white. So you could do something like this. You could make a little grid and say the number of cups and the height of the blue and the height of the white. So if it has 1 cup, how tall is 1 blue cup? 12.1. How tall is 1 white cup? 9.2. Okay, now we don't know the next one, but we can figure this out, right? If I have 2 blue cups, I'm going to start with 12.1. I put the second cup down. What's going to happen?
At 0.8 centimeters.
We're going to add how many again?
0.8.
0.8. How did we know that? Because we saw that little lip was 0.8. So what's it going to be? 12.9. How much are we going to add to the white? 1.3. So what's my new height going to be? 10.5. So I should now be able to plot this, right? 1, 12.1 and 2, 12.9. Those are two dots. As this continues to grow, is it going to grow in a linear fashion? Yes, for the most part. Is that 0.8 lip ever going to change? I suppose if you stacked 1 million of them, the weight might be so much that it would crush it down, but let's not go there. We're just going to assume that the lip is always going to be the lip, right? So this should change linearly. So you could figure out 3 and 4 and 5 and 6 and 7, but that would be way too much work, right? I don't want to work that hard. I just want to cut to the chase. I just want to know what number is it going to be where those numbers are equal. And a few of you already figured it out. Anybody else got it that I haven't looked at yet? Okay, in the interest of time, I'm not going to show you the answer. This is going to be your assignment. So, at the very bottom, see cup stacking quiz? You need to finish this quiz prior to class on Friday. So when you click on this quiz, I think there's 5 questions. Let me look at it again. It says, which of the following equations would represent the height of the blue stack if x is the number of cups, x is greater than or equal to 1? So based on what we were just working on, you should be able to come up with an equation for the blue. It's one of those. And you should be able to come up with an equation for the white. That's number 2. And then number 3 is that Swivl, the part that I told Landon to work on after he showed me his answer. And notice there are 3 questions that go with that. So it's a 5-question quiz. You need to be able to complete that quiz. Now, when you click OK and you're done, it'll spit out your grade. It'll say you got something out of, I think it's 10 points, because each one is worth 2. And if you're not happy with your grade, you can go on and you can take the quiz again. However, it's not going to tell you which ones you got right and which ones you got wrong. So you're going to have to figure that part out. But you can take that quiz as many times as you want until you get 10 out of 10. All right? And then also work on those other quizzes that I've been preaching to you about forever. And when you come back on Friday, we'll do another couple activities with linear modeling. See you then. Yep.